Alright, this is 2012 exam 2. I'm going to go through question 1A and B. Question 1 has a picture of a solenoid. This is the thing here. A solenoid is another name for a loop of wire. And they're asking, there's a solenoid here, and there's also, you've got to consider the Earth's magnetic field here. What is the magnetic field at this point P? So to do that, we have to work out each one individually. What's the magnetic field from the solenoid and what's the magnetic field from the Earth's magnetic field, and add them together. Right, so let's start with the solenoid. The solenoid is connected to a battery. If we draw the positive side of the battery over here, the negative side over here, so current runs from positive to negative. So we can draw some arrows on this solenoid here. Comes up and it goes down that way. To work out the magnetic field of the solenoid, we have to use a rule called the right-hand solenoid rule. So that's one you need to look up and be able to practice. Using the right-hand solenoid rule, your fingers point in the direction of the current, and your thumb points in the direction of the north pole of the solenoid. So if I was to grip this with my hand, my fingers would wrap around here, and my thumb, my right hand thumb, would point to this end here. So this is the north pole of this magnet. A solenoid has the same field lines as a bar magnet. So I'm going to draw it over here, just so it's not in the way when I go to write my answer down here. This is my solenoid, and the loops come around. This. And I've worked out this is my north end, so if I just change colours, draw what the magnetic field lines look like around the solenoid. It comes out of north and into south. And we could draw some others. Like that. Alright, so imagining this is the same as this guy here. At point P, there's a magnetic field line, because P is directly to the side. What's directly to the side? We've got an arrow going to the right. So I'm going to have an arrow going to the right from my solenoid. I'm also going to have the Earth's magnetic field going like this. Now these are vectors, these are arrows. How do we add arrows? We add them head to tail. So here's the head of my first arrow, add it to the tail of my second, and I get the overall answer. That's my overall magnetic field. I could have added them the other way around if I wanted. I added this one first and this one second. Right, head of the first to the tail of the second, and join them up, and see how that is the same as that. So that's your answers for the first one. Alright, Roger has a small magnet. It's free to rotate about its axis. This is shown in figure 2. And this is a question, ignore the Earth's magnetic field. That's quite important. Ignore the Earth's magnetic field. And when it says he has a small magnet that's free to rotate about its centre, what that means is we've got a compass. And a compass always points the direction of the field lines, points in direction of field lines. So he places it at point Q, figure 1, it's up here. And what do the field lines look like if we ignore Earth's magnetic field at point Q? Well, we've got the guy coming out here, we've got him coming around here, that going around there. So at point Q, the field line at point Q is going this way. Which of these magnets points in that direction? The answer is C.